Okay, so in previous videos, well, in a previous video, we saw how to solve these nonlinear systems, and again, very specifically, nonlinear systems wherein we have a linear equation and a quadratic. We saw how to solve these using the calculator to find the points of intersection, which represent the solutions in geometry, right? So now we're going to find those solutions using algebra. And by algebra, I of course mean by using substitution. So very simple. It's the same kind of substitution you would do in any aspect of algebra. So, for example, here on this first one, we see that y is equal to negative 2x minus 7. I can take this y and substitute it in for this y, which makes this a whole lot easier if you think about it. So instead of y equals negative 2x squared, I'm going to have negative 2x minus 7 is equal to negative 2x squared plus 4x plus 1. From here, now it's just a quadratic. Obviously, it's not in standard form, though. We got to get it in standard form, and then we can talk about solving it. So I'm going to add 2x, add 7 to both sides. So now I've got negative 2x squared. So the plus 2x, the plus 4x, that's going to give me plus 6x, plus 7, plus 1, plus 8. And now this here became 0. From here, negative 2, 6, 8. These are all three divisible by negative 2 because I don't like that negative leading coefficient. So I'm going to divide everything by negative 2. This becomes positive x squared minus 3x minus 4 is equal to 0. And now we've got a very, very simple to solve quadratic because a is equal to 1, right? And c has factors that will combine to give me b. In other words, the factors of negative 4 that combine to give me negative 3 are quite easily going to be negative 4 and positive 1. And using the zero product principle, I know one of my solutions is going to be 4, because 4 minus 4 is 0. The other solution is going to be negative 1. Now, this is not my answer, right? We know that we're going to have corresponding y coordinates, right? Because these solutions represent the x coordinates of points of intersection. So we have to find the y coordinates. And that's just as easily done in the same manner. So for example, I'm going to take x equals 4, plug it in here to y, and say y is equal to negative 2 times x minus 7. And we do some quick maths. Negative 2 times 4 is negative 8, minus 7. First y coordinate is going to be negative 15. So one of my solutions, my points of intersection, is going to be when x is 4, y is equal to negative 15. Easy. Do it again, except this time with the negative 1. Plug it into this same place. I'm going to say y is equal to negative 2 times x minus 7. Y is equal to positive 3 minus 7. Whoops, I don't know why I did minus 3. Sorry, it's kind of early in the morning. That would be positive 2 minus 7. And y is equal to negative 5. So that means my second solution, my second point of intersection, is going to be when x is negative 1, y is negative 5. And if I pull that up on the graphing calculator, so let's type in negative 2x minus 7 and negative 2x squared plus 4x plus 1. Okay, click and drag so we can come down here and actually see both points of intersection. And menu 6, 4. So there's one of them. Negative 1 by 5, which we've got right here. And repeat the process, menu 6, 4. And here's the other point of intersection, 4 by negative 15, which I have right here. So we see the process works. Obviously, it's more work in algebra, right? But there's going to be instances where you're going to have to use algebra. like whenever we have no points of intersection and we need to know the complex x and y coordinates that result from that. All right, on this next example, nothing's really going to change. But we're going to see, obviously, some different outcomes than what we saw in the first one. So here, right, same process. I know that y is equal to 2x plus 1, which means I can substitute for this y up here. Right, so now I can say 2x plus 1 is equal to x squared plus 6x plus 5. And again, just like in the last example, I've got to get this into standard form. So minus 2x minus 1, that's going to give me x squared plus 4x now plus 4. And now I'm equal to 0. And again, we see that a is 1. And we also see that this is easily factorable because we know we have factors of c that will combine to give me b. In this case, positive 2 and positive 2. 2 times 2 is 4. 2 plus 2 also combines to give me 4. So we have an interesting little thing come up here. We see that x is going to be equal to negative 2 twice. And that means this is a double root, right? Which means, so algebraically, if we have a double root, that means in the geometry, right, in the graph, they're only going to have the one point of intersection. Okay, and just like in the last example, I know this x value has to correspond to some y value. And I know y is equal to 2 times x plus 1. So let's figure out what the corresponding y value is. 2 times x plus 1. And 2 times negative 2 is going to give me negative 4. Negative 4 plus 1, negative 3. So I know my one real solution here is going to be x is negative 2, y is negative 3. And again, if I come here and chuck this in the calculator real quick, so I've got x squared plus 6x plus 5 and 2x plus 1. And I do menu 6, 4. And holy dog crap, there it is. My point of intersection, my one point of intersection, right, is negative 2 by negative 3. They only have the single point of intersection. They're perfectly tangent. Okay? Now, our next example. So this is where we're going to have no points of intersection, but let's just do the math and see where it takes us. Let's pretend I didn't say that. Anyway, it's the same process. I know y is equal to 4x plus 36, which means this y also is equal to that same thing. And I substitute, I simplify to get this into standard form, right? So I'm going to do minus 4x minus 36. That's going to give me negative x squared plus 14x minus 65 now equal to 0. I don't like this negative leading coefficient because it just complicates things. So I'm going to multiply everything by negative 1. Now we've got x squared minus 14x plus 65 equals 0. And from here, yes, a is equal to 1, but c does not have factors that will combine to give me b. So this is not factorable. So I'm either going to have to complete the square or do the quadratic formula. That choice is always up to you. I'm going to complete the square. It's just easier. So b is negative 14. Half of that is negative 7. All of that squared. Minus, of course, that number itself squared. So negative 7 squared is 49. And then we still have that plus 65 there chilling. Combine these two like terms. That's going to give me x minus 7 all squared plus 16 is equal to 0. Subtract 16 and then take the square root. So now I've got x minus 7 is equal to plus or minus the square root of negative 16. And then I add 7 and simplify this square root. So x is equal to positive 7 plus or minus 4i. Okay, so we've got complex solutions. We're going to have two complex solutions, which of course in the geometry means we have no points of intersection. Right, and if we have no points of intersection, then we have no real solutions, which is why we have two complex solutions. Right, so same process to get our corresponding y values. So I'm going to say 7 plus 4i first is going to get plugged in here to find my corresponding y value. So 4 times my x, so 7 plus 4i, and then plus the 36. I'm just going to distribute this 4, so that becomes 28 plus 16i plus 36. Combine like terms, the 28 and the 36. That's going to give me y is equal to 64 plus 16i. So we have our first solution. It's just a complex answer. So x is equal to 7 plus 4i. And y that corresponds to that is 64 plus 16i. And we know we have another complex solution to this that comes from doing 7 minus the 4i. And that's going to get plugged into the same place, into the same equation. So 4 times x, so 7 minus 4i this time, it's just the conjugate. And then plus that same 36. And we're going to see the outcome is also going to just be the conjugate to this. So obviously this is the conjugate to this, right? The y values are going to be the same. So 4 times 7 is still going to just be that 28. 4 times the negative 4i is going to be negative 16i this time. And then we still have the plus 36. We combine them into 64 minus 16i. So that just means my second solution is just the conjugate complement of my first one. So x is 7 minus 4i, and the corresponding y coordinate to that is 64 minus 16i. And I've got it. And again, just to prove my point, chuck it in the calculator. So we've got 4x plus 36 negative x squared plus 18x minus 29. And something went wrong when I entered this in. Oh, good Lord, I hate when it does that. Like, really? Plus 18x minus 29. There we go. Now it looks considerably less stupid. So if I just do menu 4 to zoom out, I mean, we can plainly see they're never going to intersect, right? And because we have no points of intersection, we have two complex solutions that we see here. Okay, so that's how we're going to take care of these with algebra. If you have any other questions over this, you know where to find me. Otherwise, shoot me an email. Goodbye.